Welcome to Fort Bend Tutoring. Today we will be teaching you on a new subject of which you might find interesting. Please put your cigarette down and pay attention for a minute.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about absolute value inequalities. So when you're dealing with an absolute value, you need to know that the absolute value of a function is the distance to zero. That's right. The question is asking you how far away from zero are you? And that answer is always going to be one of two things. It's either going to be zero or a positive value. So depending on the direction you're coming from, whether you're starting out at a negative value or you're starting out at a positive value, your distance can be the exact same. And for that reason, you may end up having to solve more than one equation or inequality in this case in order to solve your problem. So please keep these things in mind. When you're dealing with an absolute value and you have a greater than or equal to symbol, you're dealing with an or situation. That's right, you're dealing with a union. All right, and here's the symbol for union, by the way, that big U right there. So that means you'll need to combine your solutions for your final result. And then when your absolute value is set to a less than symbol or a less than or equal to symbol, you'll be dealing with an and scenario. And that simply means that you're looking for the solutions that overlap. All right. So in other words, what they have in common. So these are the four things that you need to keep in mind when dealing with your absolute value inequalities. And let's go ahead and start on problem number one. In problem number one, we have the absolute value of x is greater than 5. So as I approach this problem, the first thing I want to do is isolate the absolute value. That's right, I want to get that absolute value on one side of the inequality symbol. And currently, it is. So I don't have to worry about that first step. However, the second step is the most important, and that is you want to analyze the problem. You want to determine whether or not this is a valid statement. At this point, you already know that every absolute value is either going to be positive or zero. So you're going to use that to analyze the situation. For instance, is 0 greater than 5? No, it's not. However, are there positive numbers that are greater than 5? Yes, there is. So therefore, this problem is possible. Because you're looking at the distance to 0 being greater than 5, we know that that distance can be greater than 5 to the left of 0 as well as to the right of 0. So therefore, you're going to set up two different inequalities. The first one, all you have to do is drop those absolute value bars. So I'll end up with x being greater than 5. Because I have a greater than symbol, this is going to be an or situation. So I'll go ahead and write down the word or. And then I'll set up my next inequality. Remember, the first one is for the distance to the right of 0. This next inequality will determine the distance to the left of 0. So therefore, I'll have my variable x, and I need it to be less than negative 5. Because remember, we're looking for a distance that's greater than 5 to the left of 0. We know that to the left of 0, we have negative values, but we need that distance to be greater than 5. Then, after you set up your inequalities, you want to go ahead and solve for each of them. And fortunately, these inequalities are already solved for. I already have one of my variable isolated on one side of the inequality. So my result here, my solution, is x is greater than 5 or x is less than negative 5. Now you can write your answer just like that. However, some teachers in textbooks will have you graph your solution. Alright, so let's see what that looks like on a number line. We'll start out with our number line here. I'll need to represent two values, those values being negative 5 and positive 5. Now if you've seen our previous video on graphing inequalities, you would know that parentheses is one way to represent it, but some of you will be using open circles. So either way will do. In fact, I'll go ahead and show you both. Alright, so let me go ahead and draw another number line here. I'm going to draw another number line so you'll see both versions. And we'll have our negative 5 tick, and we'll have our positive 5 tick. And one way to write the solution is with open circles. Let's go ahead and do that in red ink here. On my first line, I'll go ahead and use an open circle to represent my negative 5 and 5. So I'll have an open circle here, and I'll have an open circle here. Because my first inequality says that x is greater than 5, I know that I need to shade to the right of 5 here on my number line. And then the second inequality says that x is going to be less than negative 5. So I'll go ahead ahead and shade to the left over here by my -5 there. All right, so that's your solution using open circles. Now, if you're in advanced courses, you won't be using the open and closed circles. You'll be using parentheses and brackets on your number line. So to express that, I'll have my parentheses opened up at -5, and I'll be shading toward the left. All right, that takes care of that x is less than -5 inequality. And then for the x is greater than 5, I'll have my open parentheses there, and I'll be shading toward the right. Okay, now the purpose for using the parentheses is that you may have to write your solution in interval notation. And this graph, this second graph right here, is a direct translation into interval notation. All right, so let's check it out. I'll have parentheses -infinity, comma, -5, union, parentheses, 5, comma, positive infinity, close parentheses. And this is going to be your solution for problem number 1. Let's go ahead and box up that interval notation. Just like that red box in it. So we started out with number 1 being the absolute value of x has to be greater than 5, and we solved for that by isolating the absolute value, which was already isolated, and then we went ahead and set it up as an or situation because of that greater than symbol. So we set up our first inequality to be x is greater than 5. We then wrote our or, and then set up our second inequality to be x is less than -5. So check out the fact that we changed the direction on our inequality symbol for that second inequality, and you also change the sign on the 5. Why? Because we're coming from the left of 0 in that second inequality. The first one determined the distance from 5 to the right of 0. This one determines the distance being greater than 5 coming from the left of 0. All right, so there you have it, ladies and gentlemen. From there, I showed you 2 ways to graph it, one using open circles, all right, and the other one using parentheses. So depending on your course, you know which one you need to use. All right, ladies and gentlemen, let's move on to problem number 2. In problem number 2, we have the absolute value of x is less than or equal to 4. Well, for starters, I already noticed that my absolute value has been isolated. It's on one side of the equal sign, just like it needs to be. In addition to that, I'm analyzing the inequality to determine if it's possible. Is my absolute value capable of being less than or equal to +4? Well, I know that the solutions of any absolute value can either be 0 or a positive number. So I do know that 0 is less than 4, and I do know that there are positive numbers that are less than 4. So this problem is definitely possible. In addition to that, +4 does equal to +4, and that's a positive value. So let's go ahead and set this problem up. So then you'll drop the absolute value sign and rewrite your inequalities as x is less than or equal to 4. And because you have a less than or equal to symbol this time around, this is an and situation. So I'll also have x is greater than or equal to -4. So once again, when it comes time to write that second inequality, you're going to change the sign on your inequality symbol as well as change the sign on that value. All right. So in this case, we started out with a +4. We'll then change the value and have a -4 in our second inequality that we write. We'll then want to solve for both inequalities. So it just so turns out that these variables are already isolated by themselves, so it's already solved for. So let's go ahead and see what this looks like on a number line. All right. So drawing out my number line here, I have my 2 values of -4 and +4. So then I'll reference the fact that x can be less than or equal to +4 using a bracket. But remember, you can also use a closed circle as well. So it depends on your class and your teacher and instructor which version they prefer. Since I'll be writing my final result in interval notation, it just makes sense that I'll be using a bracket to show that this can be less than or equal to +4. I'll then start shading towards -4. And as I approach -4, I notice that x can also be greater than or equal to -4. So remember, when you're dealing with an and situation, it's an intersection. It's what the 2 solutions have in common. So what these 2 solutions will do will overlap in the middle here. All right, so your solutions are trapped between -4 and +4, including -4 and +4. So this is the graph of your solution for problem number 2. If I were to write this in interval notation, then it'll look just like this. I'll have bracket -4 to +4, and I'll close with a bracket. So this is once again why I choose to use brackets on my number line when I'm graphing my inequalities. It's a direct translation into interval notation. Yeah. All right, let's go ahead and put a red box around this. Red boxing it. There we go, ladies and gentlemen. There's the answer. I'm showing off with my red box right here, and we're moving on to problem number 3. All right. In problem number 3, we have the absolute value of 3y minus 1 is greater than or equal to 8. First things first, we want to isolate the absolute value sign. It is. Second thing, we want to make sure that this is possible. How do we determine that? Well, the absolute value can be either 0 or a positive value. So, can this absolute value be greater than or equal to positive 8? Well, absolutely it can, because the absolute value can be a positive value. So why couldn't it be positive 8 or even greater than positive 8? Well, it can. So let's go ahead and solve for this inequality here. We'll begin by setting up our inequalities. Keep in mind that this is going to be an OR situation because it's greater than or equal to. So my two inequalities will look just like this. I'll have 3y minus 1 is greater than or equal to 8, or I'll have 3y minus 1 will be less than or equal to negative 8. So once again, setting up that second inequality, you change the direction on your inequality symbol as well as change the sign on that value of 8. So now it's a negative 8. All right. From there, you're going to solve both inequalities. So here we actually have some work to do, right? So I'm going to start by adding 1 to both sides of the first inequality. That gives me 3y, which is greater than or equal to 9. I'm then going to divide both sides by 3. This now gives me y is greater than or equal to 3. Yes. Or let's go ahead and solve for the second inequality. I'll be adding 1 to both sides. So yes, I will. I'm going to bring down my 3y is less than or equal to negative 7. I'm going to divide both sides by 3 now. And now I have y is less than or equal to negative 7/3. So this is my solution, ladies and gentlemen. I end up with y is greater than or equal to 3, or y is less than or equal to negative 7/3. And now we'll go ahead and graph this on a number line. So on my number line, I will have my two values, negative 7/3 and positive 3. So now I have negative 7/3 and positive 3 on my number line, and my solution states that y can be greater than or equal to positive 3, or y can be less than or equal to negative 7/3. So let's go ahead and show that on our number line here. I'll begin with a bracket at negative 7/3 that points to the left. Why is that? Because y is less than or equal to negative 7/3, so that'll be to the left of negative 7/3. Or y can be greater than or equal to positive 3, so I'll have a bracket at 3 and then shade to the right, like so. So here's my graph of my inequality. So I end up with negative infinity to negative 7/3 with a bracket, union, bracket, 3 to positive infinity. All right, just like that. Keep in mind that when you're dealing with infinities, you must use parentheses. And depending on your inequality symbol, whether you have less than or equal to or greater than or equal to, that's when you'll use brackets at those critical values. Okay, so that's the answer. Let's red box it. So I got my box working for me right there. All right, that's problem number 3, ladies and gentlemen. Let's move on to the next one. All right. In problem number 4, we have the absolute value of negative 2x minus 4 is less than negative 6. Your first step is to guarantee that your absolute value has been isolated, that it's on one side of your inequality symbol. And it is by itself. That's good. The other thing to do is to analyze it to see if it's possible. We know that the results of every absolute value will be either 0 or a positive value. So, is there any way that 0 is less than negative 6? No, 0 is not less than negative 6. Is it possible that a positive number would be less than negative 6? No. It's not possible that a positive value would be less than a negative value. That's impossible. So, since these are the facts of the problem, this is not possible. It's impossible. Therefore, your answer is the null set. In other words, you have no solution. So, I'm going to use the null set for my answer here. Just like that. It's no solution to this problem. So, I'll just go ahead and box it up. That's all I had to do to that problem. was to analyze it. So make sure that your absolute value is isolated, then analyze the problem, and if it violates our conditions for a valid problem, then it's the null set. It's no solution. There's nothing else to do. Let's move on to the next problem. It's problem number 5. All right, in problem number 5, we have the absolute value of negative 5x plus 3 is less than or equal to 12. So in this problem, our absolute value has been isolated on one side of the inequality symbol, and it is possible because they're asking if this absolute value can be less than or equal to 12. Well, we know it can because 0 is less than 12, and there are positive values that are less than 12 and that equal to 12. So that being the case, let's go ahead and set up our problem, and keep in mind that this will be an intersection. We'll have an and involved. So we'll set it up as negative 5x plus 3 is less than or equal to 12, and we'll have negative 5x plus 3 is greater than or equal to negative 12. All right, so those are our two inequalities that we need to solve for this problem. So let's begin. I'll subtract 3 to both sides of the first inequality. I'll bring down negative 5x, which is less than or equal to 9, and then I'll divide both sides by negative 5. Remember that anytime you divide or multiply both sides of an inequality by a negative value, you'll need to change the direction of the inequality symbol. So I'll end up with x being greater than or equal to negative 9/5. And, all right, the result of our second inequality. So for the second inequality, I'll subtract 3 to both sides of the inequality here. This brings down negative 5x, which is greater than or equal to negative 15. I will then divide both sides by negative 5, and I'll have x is less than or equal to positive 3. So here's my solution. X is greater than or equal to negative 9/5, and x is less than or equal to positive 3. From here, we'll graph our solution on a number line. So here's my number line right here. I'll have negative 9/5, and I'll have a positive 3. My solution states that x is greater than or equal to negative 9/5. So that means I'll use a bracket at negative 9/5, and I'll start shading toward the 3. As I approach the 3, I have x can also be less than or equal to positive 3. So that means I'll need a bracket at 3, and it'll be trapped between those two values. So for my interval notation, bracket, negative 9/5, comma, positive 3, bracket, and done. That's my interval notation. That's the solution. Red box it. Red boxing it. Just like that. All right. That's problem number 5, ladies and gentlemen. Let's keep this party moving. Problem number 6. For problem number 6, we have the absolute value of x plus 5 minus 6 is less than or equal to negative 1. Your first step is to isolate the absolute value. Get it on one side of the inequality symbol by itself. In order to do that, for this problem, I'll be adding 6 to both sides of the inequality symbol here. I can bring down the absolute value of x plus 5 is less than or equal to positive 5. Now, at first glance, you may have thought that this problem was impossible, that we would end up with no solution because we had it set to negative 1. However, you're supposed to isolate your absolute value first, and that's why we ended up adding 6 to both sides of the inequality symbol, and lo and behold, once we did that, we ended up with an inequality that's possible to solve. How do I know this? Because the end result of any absolute value will either be 0 or positive, and 0 is less than 5, and there are positive values that are less than 5 as well, and then of course 5 does equal to 5, so we can definitely solve this inequality. All right. We'll set up two different inequalities for this absolute value here. The first, I'll drop the absolute value sign and write it as x plus 5 has to be less than or equal to 5, and remember we're using an intersection here because it's less than or equal to. X plus 5 is greater than or equal to negative 5. All right, so remember, when setting up your second inequality, you change the direction of the inequality symbol and you change the sign on that value of 5. All right, then you'll solve for both inequalities. So I'll subtract 5 to both sides. I end up with x is less than or equal to 0, and I'll subtract 5 to both sides of the second inequality, and I'll have x is greater than or equal to negative 10. So here's my solution. X is less than or equal to 0, and x is greater than or equal to negative 10. So let's go ahead and graph this on our number line. All right, so here we go. We have our number line here. I got 2 ticks that I need. I need negative 10 and 0. So x is less than or equal to 0. So I'll need a bracket at 0, and I'll be shading towards the negative 10. And x is greater than or equal to negative 10. So that means I need a bracket at negative 10 that's shading towards 0, and they're going to be trapped in between once again. So that finishes our graph. But for the interval notation, you'll write it like this. We'll have bracket negative 10, comma, 0, close bracket, and done. That's your interval notation. Let's go ahead and box it up. Red boxing it. Done. That's problem number 6, ladies and gentlemen. Done and done. Moving on to problem number 7. Just killing these problems over here, right? All right. So in problem number 7, we have the absolute value of 5x minus 8 plus 9 is greater than 7. Your first step is to isolate the absolute value symbol. So that means that I'm going to subtract 9 to both sides of this inequality. The 9s will cancel out. I'll bring down the absolute value of 5x minus 8 is greater than negative 2. So now that our absolute value has been isolated, we're going to determine if this problem is possible. So we know that the end result of every absolute value is going to be either 0 or a positive value. So let's think about this. Is 0 greater than negative 2? Yeah, well, yes it is. Second question. Is a positive number greater than negative 2? Well, yes, it is. Well, being as though the absolute value can only be 0 or positive, well, that means that any number that you plug into this absolute value will be greater than negative 2. Every single number you can put in there will be greater than negative 2. That means that your answer to this is all real numbers. If you were to show this in interval notation, you would have negative infinity to positive infinity. That's it. That's all you have to do for this problem. Because we analyzed the problem to determine our solutions, it turns out that any number will be a solution to this inequality. No matter what number you plug in here, it'll be true. It's going to definitely be greater than negative 2 because all absolute values have a result of either 0 or a positive value, and both of these conditions are greater than negative 2. So that's why your answer is all real numbers. I'm going to go ahead and box up my result. All right, so depending on your class, you can use either the all real number symbol, or you can go ahead and show it in interval notation as negative infinity to positive infinity, and done. That's problem number 7. Let's keep it moving. All right. For problem number 8, we have the absolute value of x plus 7 is less than or equal to 2. Your first step is to isolate your absolute value sign. So that means I'll be subtracting both sides of the inequality, and then I'll bring down my absolute value of x is less than or equal to negative 5. All right. So we have our absolute value isolated. That's the first step. Second step is to analyze it. Determine whether this is possible. We know that the absolute value will either be 0 or a positive number. So is 0 less than or equal to negative 5? No, it's not. Is a positive value less than or equal to negative 5? No. No, it's not. Therefore, this answer is the null set. You got it. It's no solution, ladies and gentlemen. There's no solution to problem number 8. Can't solve it. You just can't do it. Red boxing it. Done and done. That's problem number 8. Next problem. Problem number 9. We have the absolute value of 2x minus 6 is less than or equal to 0. All right. Well, our absolute value has already been isolated. It's by itself. Next, we want to determine whether or not it's possible. We know the end result of every absolute value will be either 0 or a positive value. So therefore, this absolute value can definitely equal to 0, but could it ever be less than 0? Well, we know it can't be less than 0 because your possibilities are either 0 or a positive number. So we're never going to be less than 0. It's never going to be less than 0. So in fact, you could go so far as to rewrite this as the absolute value of 2x minus 6 has to be equal to 0, because there's no way it's going to be less than 0 ever. So basically, you need to solve this equation instead of that inequality, because that inequality is never going to occur. All right? So since we do have the possibility of the 2x minus 6 being equal to 0, we'll solve for this. Our next step will be to drop the absolute value. We'll have 2x minus 6 equals 0. And then you'll solve for this. That's right, just go ahead and solve for this equation. So you'll have the following. You'll add 6 to both sides of the equal sign. You'll bring down 2x, which equals 6, and then divide both sides by 2. You'll find that x equals to 3. That's it. X equals 3. That's problem number 9. Red boxing it. All right, there you have it. Problem number 9 is done. And so we're moving on to our last problem. All right, problem number 10. In problem number 10, we have the absolute value of 4 3/10 x plus 9 8/10 is less than 0. Your first step is to isolate the absolute value. It is isolated. Your second step is to analyze the inequality. So we know that the absolute value can either be 0 or a positive value. So is 0 less than 0? No, it's not. Is a positive number less than 0? No, it's not. So that means that our answer here is the null set. It's undefined. There's no solution. So I'm using the null set. There you go. Red boxing it. Can't do it, ladies and gentlemen. So this is the end of our lesson today. And as always, please rate, comment, and subscribe, ladies and gentlemen. Any donations that you provide help us bring you more free math videos from me, Mr. Witt, and Fort Bend Tutoring. Peace.
We appreciate your time. Don't you want to learn mathematics the correct way? You need a foundation. Do not just be guessing at your numbers. Contact us today. Look us up on your Facebook at Fort Bend Tutoring. Learn it well, honey.